We discover plutonium in 1930. It is weaponized, turned into a bomb, and deployed 15 years later. That is the pace of what's going on at the time. The two bombs was a uranium bomb and a plutonium bomb. We knew uranium would work. We were not sure about plutonium. It was new boy on the block. And so that's what was tested at, famously now portrayed in the film Oppenheimer. They tested the plutonium bomb, not the uranium bomb. That's the one that then was dropped on Nagasaki. Point is, between 1930 and 1960, we cracked the atom, weaponize the atom, break the sound barrier, go into space. Oh my gosh, is there anything about 1960 that would be recognizable to anyone from 1930? I think not.
What's inside a black hole?
Equations tell us what's in a black hole, but we've never tested this, just so you know. It tells us that within a black hole, a whole new space-time can open up in the future history of this universe. By that reasoning, we, in this universe, may be the other side of a black hole that lives in somebody else's universe. So that is perhaps the most intriguing part of the equations that give us black holes. A lot of people want to know what happens after they die. You put together all scientific evidence, biological and physics and thermodynamic. You have no existence after you die. You can believe what you want in a country where we have protection of religious expression, but if you want to ask science what science says about it, you go into a state of non-existence. You can say, well, why is that? What's that like? I'll tell you exactly what it's like. This is what it was like before you were born. You're not asking yourself, what was it like before I was born? I had to have some existence. You didn't. You have no existence. A state of non-existence before you were born. So I'm not given reason to think that your state of non-existence in death differs in any fundamental way from your state of non-existence before you're born, giving that much more meaning to what it is you can and should do while you're alive in this world.
What's the most distant star you can see with the naked eye?
So that's an interesting question. I can answer that two ways. So one of them is the most distant thing you can see with the naked eye is our nearest red-blooded galaxy, the Andromeda Galaxy. For the longest while, until the early 1920s, it was called the Andromeda Nebula. It was just this fuzzy thing in the night sky among the stars that trace out the constellation Andromeda. So we named it after Andromeda. And then with better and better telescopes, wait a minute, this thing is composed of stars. Wait a minute, this thing is far away. Wait a minute, this is an entire other galaxy. It's not just a fuzzy thing in the Milky Way, it's another Milky Way. Well, how far away is it? It was not close like the stars we see in the night sky. This is outside of our entire galaxy. The stars you see in the night sky are tens, hundreds, a few, or thousands of light years away. The Andromeda Galaxy is 2 million light years away. And you can see that with the naked eye. Planet Uranus is discovered. Within a few years, a brand new element is discovered. Turns out to be unstable. We would use the term radioactive later on, but they named that after the new planet that was discovered, element uranium. 100 years after that, we discover another planet. We name it Neptune. The next element in the periodic table heavier than uranium, now number 93, was not yet named and not yet discovered till just after that planet. So they named that after the next planet, and that would be Neptunium. And there's element 94, not yet discovered, waiting its turn. The object formerly known as a planet called Pluto was discovered in 1930. Shortly after that, we discover element 94. It's named after the 9th planet, plutonium. So the periodic table preserves uranium, Neptunium, and plutonium in sequence, with Pluto an element named on false pretense. Do you know that planet-wide greenhouse effect was first discovered on Venus? Venus has a really bad greenhouse effect. It's 900 degrees Fahrenheit on Venus. And I did the math. Venus is saw it. You can take a 16-inch pepperoni pizza, put it on the windowsill, and it will cook in 9 seconds. That's hot. Do you realize if you took Earth with all of its mountains, valleys, and hills and shrunk it down to the size of a cue ball, it would be smoother than any cue ball ever machined? The distance between the lowest point on Earth's surface and the highest point on Earth's surface is 11 miles. That is less than the length of Manhattan, yet we are 8,000 miles in diameter. If you were a cosmic giant and you came up to Earth and you rubbed your finger over Earth's surface, it would feel as smooth as a cue ball to you. All our flags are either down or faded beyond recognition on the moon. China is making a flag with threads made from the rock called basalt. They're making threads out of rock. When they deploy their flag, it will be good for 1 billion years, as long as the rocks are good.
And it'll cost $5.
Let me tell you how smart Einstein was. In one of his equations, he put in a term that he later regretted putting in, and he called it his greatest blunder. He looked at his equations, and his equations showed that the universe had to be either expanding or collapsing. No one had any idea that the universe, which is everything, would be doing anything. So he says, this can't be right. Let me put in this term. It's a legitimate mathematical term, but physically, what the hell are you doing, Albert? And he says this term will help stabilize it from collapse. And it's a pressure force to push outward, and that'll stabilize it. Later on, just a couple of years later, Hubble discovered that in fact the universe was expanding, and he didn't need the term because he could have predicted that the universe should either be expanding or contracting, but he didn't. He put in this term. He said it's his biggest blunder. You know what Einstein's actual biggest blunder is? Saying that that was his biggest blunder.
Yeah.
Because in fact, in 1998, we discovered a pressure in the universe pressing against gravity that is exactly the term that he put in. That's badass smart.